For Chapter 7, I had Section 4. It began with the Premack principle. David Premack's theory provided a new way to think about how reinforcers work in operant learning. Premack suggested that the real contingency is between two behaviors. Reinforcement occurs when the instrumental act allows access to a more preferred behavior. The animal's preferences can be tested ahead of time by giving the subject voluntary access to both behaviors and then seeing which behavior it spends more time doing. Premack's theory allows the prediction of what kinds of events will be reinforcing, and it has large generality. He found that a behavior was only reinforcing if it had been preferred to the operant behavior in the original tests, when the instrumental act allows access to a more preferred behavior. Premack's approach used no theoretical constructs. All that mattered were the subject's current preferences, regardless of what the actual behaviors were or how their levels showed. Premack would predict that food, for example, would be more reinforcing to hungry subjects rather than staying rats. He also addressed punishment. His idea was based on the reinforcement rule. Punishment will occur when the instrumental behavior leads to a less preferred response. For example, delivering a mild electric shock after a lever press behavior punishes the lever pressing, not because the show is assertive, but because it elicits a behavior, such as fear, that is less preferred to lever pressing. There are a few problems with Premack's principle. One problem with the principle was how to arrange preference tests. A second problem was that many early experiments did not take into account the fact that when you make a preferred behavior contingent on another behavior, you necessarily deny access to a preferred behavior that would ordinarily fill some time. The results being that access even to a less preferred behavior can be reinforcing if the baseline level has been denied or deprived. The next segment talked about the behavioral regulation theory. The response deprivation hypothesis was summarized by Timberlake and Allison. The response deprivation hypothesis is that every behavior has a preferred level, and once access to it is restricted, we will perform another behavior to try and get back to it. Behavioral regulation theory is the general view that when a reinforcement contingency denies an activity, we will do what we can to get back. This suggests that we are motivated to defend and regulate a certain distribution of activities. In an example situation, an animal must perform behavior A to have access to behavior B. However, the schedule constrains the animal's behavior. It makes it impossible for the animal to return to the bliss point. According to the minimum distance model, the animal should make the number of A responses that gets it the minimum distance from the bliss point. This will get it as close to the bliss point as possible. Graphically, the closest point on the line will be the point that allows a perpendicular line to form the line and hit the bliss point. The minimum distance model predicts that the organism will perform the number of A responses that will get it closest to the bliss point. Stanton suggests that experiments with ratio schedules seem to follow the minimum distance model. However, it can also be applied to interval reinforcement schedules. The matching law seems to do a better job describing behavior on interval reinforcement schedules, while the minimum distance model does a better job describing behavior on ratio schedules. The next segment was selection by consequences, another view on how reinforcers may operate with the parallel between the effects of reinforcers and evolution by natural selection. Stanton and Simhag suggest that, as with evolution, an organism starts with a variable set of behaviors from which reinforcers can then select. The initial behaviors are brought about by the principles of variation that are analogous to those provided by genetics and heredity in evolution. Reinforcers then select from these variations just the way natural selection occurs, and behaviors that do lead to reinforcement are extinct, or do not lead to reinforcement are extinct. The non-eliminated behaviors remain in the population, and new variations are produced through the process of induction and generalization. This cycle then continues. Skinner also emphasized the parallel between evolution and operant learning. He believed that both processes involved the principle called selection by consequence. Selection by consequence just happens. There is no causal agent required. Dawkins learned further about the complexities of variation and selection. He created a computer program that generated simple biomorphs by variation and genes that were built into the program. He ran a number of variation and elimination cycles, and in the end, complex organisms emerged. Because of variation selection idea developing, there has been progress in understanding some of the principles of variation, and investigations now recognize that reinforcers function to select as well as strengthen operant behavior. That was it for this segment.